This video is on segment 3, pages 123 to 131, chapter 4, Theories of Conditioning. Attention is usually in the information processing model of memory that became popular in psychology in the 1950s. A simple version of memory is that the stimuli from the environment first enters sensory memory, a hypothetical memory store that briefly holds visual and auditory information as echoes or images. If those stimuli in the sensory memory are attended to, they enter another hypothetical memory store called short-term memory. Short-term memory is the space where thinking occurs. An example is remembering a telephone number between looking it up in the telephone book and dialing it on the telephone. Information in short-term memory doesn't last very long, so unless you rehearse the telephone number, you'll forget it easily. Short-term memory also has a limited capacity. Long-term memory is very different from short-term memory. Information lasts almost indefinitely, and it has an enormous capacity. CS-US associations are assumed to be stored in long-term memory. Store of information in long-term memory depends on the preceding chain of events. The stimuli must enter the system. The stimuli must be attended to, and the stimuli must be processed somehow in short-term memory. If the information isn't processed enough in short-term memory, it won't get transferred to long-term memory. Alan Wagner used this framework to extend the Rescorla-Wagner model. Surprising events get extensive processing in short-term memory and increase its chances of being stored in long-term memory. Surprise is easy to conceptualize in the information processing framework. An event is surprising if you aren't already thinking about it. Within the information processing system, an event is surprising only if it is not already present in short-term memory. Learning depends on the event being surprising, but the surprise is reduced if the event is already present in short-term memory when the event actually happens. An event already in short-term memory is said to have primed in short-term memory, and priming reduces surprise. There are two ways that stimuli can enter the short-term memory. The first is the external world through sensory memory. The second is when it is called up out of long-term memory through memory retrieval. It is primed by a retrieval cue pulling it out of long-term memory. In the information processing theory, the CS will pull the US out of long-term memory and prime it to short-term memory. Retrieval-generated priming. Surprise can be reduced in two ways. A retrieval cue can call it out of long-term memory. Recent presentation of the event can prime it. Priming of the US. Blocking occurs in two phases. Phase 1 is when a noise is associated with the US. When the noise is presented, it then retrieves the US representation from long-term memory and puts it into short-term memory. Phase 2 is when the light and the noise are presented together. The noise immediately primes the US into short-term memory. When the US happens at the end of the trial, it is therefore not surprising. Blocking is a classic example of retrieval-generated priming. A new model suggests that surprisingness of the US should also be reduced by self-generated priming. W.S. Terry investigated this with an experiment. He had rabbits receive an eye blink conditioning with two CSs, A and B. Trials A and B were intermixed. 4 seconds before every A-US trial, Terry presented the US. Trials with B-US were not preceded by a US. Terry predicted that the US before the A-US pairing would prime the US in short-term memory, making an occurrence with A less surprising. The rabbits learned more slowly about A than B. In another experiment, Terry presented a distracting click and vibration between priming the US and the A-US pairing. The click and vibration allowed the rabbit to learn about A. Terry suggested that these stimuli entered short-term memory and knocked the US out after it had been primed. At the end of the A-US trial, the US was surprising again. Wagner's ideas about short-term memory, priming, and the surprisingness of the US were nicely confirmed by Terry's experiments. Priming of the CS. The Rescorla-Wagner model emphasized the surprisingness of the US. The priming model expanded on this by giving both retrieval-generated and self-generated priming. It claimed that the surprisingness of the CS was actually equally as important. Learning depends on the joint proceeding of CS and US in short-term memory. Surprisingness of US and CS are important in surprising. Latent inhibition, according to the newer model, is exposure to the CS before conditioning should rescue its surprisingness. Latent inhibition happens because the CS becomes less surprising. New ideas about latent inhibition came about because of self-generated or retrieval-generated priming. In a vinegar experiment, Group 1 received vinegar and then given an illness 30 minutes later. Group 2 received vinegar once and then 4 hours later again, and then given the same illness 30 minutes later. In Group 3, the subjects received vinegar once, then received a distracting vanilla taste after, then 4 hours later were given the vinegar again, and then given the illness. The results show that the priming reduced the conditioning of taste aversion, but the distractor reduced the priming effect. Group 2 acquired a weaker aversion than the first group. The vinegar experiment in relation to the priming model. The first exposed priming vinegar is in short-term memory, making it less surprising. This can be seen as a slight stretch because short-term memory does not often last for 4 hours. However, tests suggest that flavor memory lasts a while. Because of short-term memory's limited capacity, the distracting vanilla taste being presented right after the vinegar knocks it out. The vinegar representation, this made the vinegar later on more surprising. Ways to test this is pre-exposure to the CS in one context, box A, and then pair the CS and the US in completely different context in box B. Box B should be unable to prime the memory of the CS, and the CS should therefore be conditioned at an ordinary rate. If CS pre-exposure and conditioning occur in a different context, conditioning occurs at a more rapid rate. Habituation. Habituation is repeated exposure to a stimulus, usually leading to a decline in strength of the response it originally elicited. Habituation results in decrease of surprise. Repeated exposure makes it become less and less surprising. Whitlow examined the idea that habituation resulted from self-generated priming. Exposed rabbits to 1-second tones that caused vasoconstriction response in the ear. The rabbits were exposed to jumbled series of high and low pitches tones 60 seconds apart. In relation to the priming model, presenting the tone would prime it in short-term memory, making it less surprising for a little while. This should have made the tone less surprising, but not the other tones less surprising. The study showed less vasoconstriction occurred when a tone had been preceded by itself rather than by a different tone. When distracting stimulus was presented, there was less difference between the same and different conditions. Habituation was caused in part by self-generated priming in short-term memory. Habituation can also be due to retrieval-generated priming because habituation can often last a long time between exposures. An animal might form an association between the stimulus and the background context. The context would retrieve the stimulus from long-term memory to short-term memory, and this would reduce its surprisingness. Habituation should be context-specific, and when you change the context between repeated exposure and a final test should make it impossible for the context to cause priming. There has been trouble confirming context-specific habituation because it has implications that go beyond habituation itself. The priming model argues that latent inhibition happens because of pre-exposure to the CS that habituates the surprisingness of the CS. Habituation and latent inhibition results from separable processes. Latent inhibition is context-specific and habituation is not context-specific. Summary. Short-term memory model expanded on the surprise idea first built into the Rescorla-Wagner model. Surprise became more than a mathematical quantity. It depended on if the event was already in the short-term memory. Surprise can be reduced by either of the two priming mechanisms. Surprisingness of the CS and the US for the first time was included in this theory. By the mid-1970s, classical conditioning was being interpreted from a cognitive framework. Wagner's model was the reason that it became conventional to speak of short-term memory, rehearsal, and retrieval when discussing conditioning. Conditioning is now thought to depend crucially on how memories are processed in short-term memory. Nodes, connections, and conditioning. Long-term memory focuses on associations that are hypothetically stored there. Nodes are memory representations that are activated when the stimuli are present. An association between nodes is often known as connection, which vary in strength due to learning. When a CS is presented, its node is activated, and activation travels down existing associations to activate other nodes. Activation of the node is only temporary and is thus analogous to being in short-term memory. Nodes are activated when the item occurs in the external world, self-generated priming, or when another node associated with it has been activated, retrieval-generated priming. Wagner's SOP model, or the standard operating procedures. It accepts the idea that a CS or a US node become activated when the stimulus is presented in the real world. The model believes that activation has two levels of intensity. When a CS or US is first presented, the node is activated in an A1 state. A1 means a high level of activation. When activation soon declines to an A2 state, this is basically being in peripheral tension. The node stays longer in the A2 state. The node then returns to the inactive state where it remains there indefinitely until the stimulus comes again. The order of the node must be A1, A2, and then inactive.